Hello. Today we're going to look at simplifying rational expressions. Rational meaning fraction. So we're going to start with a super simple one here. I have just the directions to evaluate. And we're going to evaluate the fraction 9 plus 6 all over 3. So what we can do is we know that we can take 9 plus 6 first to get 15 and then divide by 3 to get 5. Okay. When we do fractions, there's an assumed set of parentheses on the top and on the bottom to let you know that you have to do everything on top first, everything on bottom second, and then the division last. So we can also look at this in a different way. So since we have 9 plus 6 in parentheses divided by 3, 9 and 6 have something in common. They have a 3 in common. I can factor out a 3 from both 9 and 6. 9 divided by 3 makes 3. 6 divided by 3 makes 2. Right? If I were to distribute that back through, you're going to get 9 plus 6 again. Still divided by 3. And you can see how we have a 3 divided by 3, so it cancels. And all we're left with is 3 plus 2 to make 5. The reason I'm showing you this is because all too often I see something like this, where you see, oh, we have a 3 and a 6 here. Well, I can cancel the 3 and the 6. This becomes 2. And all of a sudden, I have 9 plus 2, which makes 11. Well, this is not the same thing, right? We know the answer has to be 5, so there's no way it can be 11. So in order to divide, we have to be able to take out something from the entire fraction, both top and bottom. So if we took out our 3, we would have to take out a 3 from there and from here. And so now we're left with 3 plus 2, which does equal 5. Let's take a look at some harder examples using some variables. So the directions now have changed to simplify. We can't evaluate because we don't know what our variables are going to equal, right? They're unknowns. So we have 4x minus 20, all divided by 4. We can do this in a couple different ways. We can notice that, oh, there's a 4 on top that divides out of everything. So I'll factor this into 4 times x minus 5. Right, factor out the GCF of 4. If I distributed that back together, we would get 4x minus 20. Still all over 4. Now we have a 4 divided by 4, so we're taking a 4 out from both top and bottom. And so all we're left with is x minus 5. Now if I didn't factor out the 4 like that, what I'm looking at is 4x over 4 minus 20 over 4. I can break that apart like that. If I put it back together, we already have our common denominator, so I would just do 4x minus 20. But then we're taking a 4 out from both things. So there's our 4 that can divide out, leaving us with x. That minus sign drops down, and then 20 and 4 becomes 5. And so once again, we get x minus 5. So again, two different ways to do that. In the next one, well, goodness, between 7y and 42, I can take a 7 out. GCF is 7, leaving me with y plus 6. In the denominator, we have a GCF of 8, leaving me with y plus 6. Well, what's the same on top and bottom now? It's a y plus 6 that can cancel. And we get the fraction 7/8. Now I can't break this one apart into 7y over 8y plus 48. I mean, I can, but it's not going to do me any good to do this. Because now we're not going to find anything in common on top and bottom still. So this top version is really the only method of attack we have. One thing worth noting in this problem, because the denominator is 8 times y plus 6, we know that our denominator can't be equal to 0. So we know that y plus 6 can't be equal to 0. So y can't be equal to negative 6. So let's take a look at one more. In this particular problem, x squared minus 4x plus 3, all divided by x squared plus x minus 12. It wouldn't serve us well to split this up into 3 separate fractions, because once again we're not going to find something divisible by all 3 parts. But what we can do is go through and factor. I can factor the numerator. The GCF is 1, but we can come up with 2 numbers that multiply to positive 3 and add to negative 1. And those numbers would be minus 3 and minus 1. So that factors into the quantity x minus 3 times the quantity x minus 1 over. And our denominator, GCF is 1, but again, we can find numbers that multiply to negative 12 and add to positive 1. And those numbers are negative 3 and positive 4. So once again, we look on top and we see that we have the same number, in this case an x minus 3, being multiplied into a different number. So we can cancel the x minus 3's, because whatever that is, that's the same number that we're taking out of both top and bottom. And so we divide out and they become 1's, and what are we left with? Well, the numerator has an x minus 1, the denominator has an x plus 4, and that's it. You may be wondering to yourself, well, why can't I cancel out these x's? And the answer has to do again with those assumed set of parentheses that we're talking about in the numerator and denominator. We would need to do the subtraction on top first, then the subtraction on bottom second, before we did any division. So how is it that we could cancel over here instead? Well, the x minus 3's, we're doing multiplication. Multiplication and division are interchangeable steps. So instead of doing the multiplication first, we just decided to do the division first to cancel them, leaving us with the x minus 1 over x plus 4. Okay, we'll do more of these examples in class. We are done here.